Now let's talk about ionization energy, which is the energy required to remove an electron from an atom. As you move from left to right across the period, ionization energy increases. Why? Because atoms on the right side of the periodic table hold on to their electrons more tightly, especially elements like neon and argon. For instance, it's much easier to remove an electron from sodium than from chlorine, which is just one element to its right. Sodium readily loses an electron, while chlorine is just one step away from being stable, like the noble gases. Can you think of why noble gases like neon have such high ionization energies? Drop your thoughts in the comment section. Closely related to this is electronegativity, or the ability of an atom to attract electrons in the chemical bond. Just like ionization energy, electronegativity increases as you move across a period. Let's take fluorine for example. Fluorine has the highest electronegativity of all elements, making it very reactive. Now let's talk about the exceptions to these trends. While periodicity gives us a clear patterns, there are some interesting exceptions. For instance, the ionization energy of oxygen is slightly lower than that of nitrogen, even though oxygen is further to the right. This happens because of electrons' repulsion in oxygen's p orbitals, making it easier to remove an electron. This is fascinating. So, what have I been talking about? I said atomic radius decreases across a period and increases down the group. Ionization energy and electronegativity increases across a period and decreases down a group. These trends are the key to understanding how elements behave. So, now it's your turn. Based on what we've discussed, try predicting the behaviors of these two elements, magnesium and sulfur. How do their atomic radius, ionization energy, and electronegativity compare? Drop your thoughts in the comment section. So, everyone, periodicity helps us decode the behavior of elements and predict how they will interact in the world of chemistry. If you want to go deeper into these trends or explore specific elements, don't forget to subscribe and hit the notification bells for more exciting chemistry lessons. See you next time. Bye.